Hey you guys, so in today's video we're going to talk about absolute value. I'm guessing most of you have heard of absolute value before, but our formal definition of it is that absolute value is a number's distance from zero. So we got a few practice, like just easy absolute value problems on the front here. So the first one says absolute value of 4. Well, how far is the number 4 from 0? It's 4 units from 0. So my answer is 4. Then the second one says absolute value of -3. How far is -3 from 0? So we look at a number line and it's 3 units from 0. So you've maybe heard in the past absolute value makes stuff positive. In a way it does because distance is always positive. Okay, now look at this third problem. It says absolute value of 10 minus 6. All right. So here's where it's dangerous to think absolute value makes stuff positive. It does not turn this minus sign into a plus. We have to do 10 minus 6 first. So this problem really becomes absolute value of 4, which is 4, because the number 4 is 4 units from 0. Here's 0, here's 4. It's kind of the same as the first problem. Okay, so we're going to do some absolute value equations now. Equations are going to have x's in them that we're going to have to solve for. So here's our first example. It says absolute value of x equals 5. So I'm looking for what numbers have a distance of 5 from 0. So if I draw out on the number line 0, we got to look for what numbers are 5 units away. Well, there's a number here, it's 5, but there's also a number 5 units to the left. That number is -5. So there's actually two answers that work to this problem, 5 and -5. So my solution is x equals 5 or -5. We use the word or because you can't really have both solutions at the same time. It's not and, it's or. Either the answer is 5 or the answer is -5. Both of those numbers make this a true equation. So when we look at number 2 here, it says absolute value of x equals -3. So if I were to draw 0 on the number line, I'm looking for what numbers have a distance of -3 from 0. And then you kind of say that again, a distance of -3. Can you have a distance that's negative? You can't. So this problem, anytime absolute value equals negative, it's going to be no solution. Okay, on the next page, we'll get a little bit harder. So when we get to a problem that looks like number 3 here, absolute value of x plus 3 equals 12. We have to kind of think back to that number line from the previous page, all right? What we found out is that that inside number, that x, could be two opposite numbers. Opposite meaning one positive, one negative, right? The inside was two opposite numbers. So the way we're going to solve these when it has something more than just x in the middle, okay, so any absolute value equation, we're going to solve it like this. The inside can be two opposites. So I write my first equation as just x plus 3 equals 12. Okay, that's the first, the regular, the positive version. But then I need the opposite of that. Well, opposite means negative. So I go negative parenthesis x plus 3 equals 12. Notice I have two equations because I'm going to get two answers. And the first equation is the regular x plus 3, or positive x plus 3. And the second equation is the opposite of that, or negative parentheses x plus 3. So then to solve this, the first one, I just subtract 3 from both sides, and I get x equals 9. The second one, I'm going to distribute the negative, so I get negative x minus 3 equals 12, and then I can add 3 to both sides, so I get negative x, add 3 to both sides, so I get negative x equals 15, and then I can divide by -1, and I get x equals -15. So there's my two answers, but the or between them, x is 9 or x is -15. So those are the two answers that make this equation true. And let's do a little mental math here. Let's put 9 into this equation for x. 9 plus 3 is 12. and the distance from 0 of 12 is 12. So 9 works, and then let's do with negative 15. Negative 15 plus 3 is negative 12, and the distance from 0 of negative 12 is 12, so that works too. Okay, so both of those solutions make this equation true. So let's try this again on number 4. I'm going to do two equations, once with the positive version of the inside, once with the negative. Sometimes I like to draw little arrows representing splitting it into two equations. Any absolute value problem, you have to do this. You have to split it into two equations. So I'll get my positive equation, which means I change nothing, and my negative equation, which means I put negative in front of the absolute value, what was inside the absolute value. Okay, notice it turns into parentheses now. Okay. So here I'm going to solve the one on the right, the one on the left by adding 4. I get 5x equals 20. Divide by 5, I get x equals 4. Okay, I'll show you a little trick on number 4 here with this one. I could distribute the negative. You can also divide by negative 1 right away, and that's going to cancel that negative out, and so I get 5x minus 4 equals negative 16, and then I add 4, so I get 5x equals negative 12. Divide by 5, and we get x equals negative 12 over 5. So there's one answer, there's my other answer. Okay, both of them work. One more problem. All right, and then in this last problem here, we've got kind of a lot more going on. You'll notice we have stuff outside the absolute value. And so when I talk about outside the absolute value, I'm looking at like this 2 that's multiplied in front, and this plus 4 that's added after the absolute value symbols. And so one thing that's really important to remember is that this 2 means multiplication. This is 2 times the absolute value. Okay, and then the other really important thing to remember is that you cannot distribute into absolute value. Okay, so that's something that a lot of people are going to want to do, is try to distribute that, and you can't. So our first move is really to try to get the absolute value alone. And so I'm looking at this absolute value piece. I want to get rid of the 2 and the 4. And so it's almost like if I were just solving a regular equation like 2x plus 4 equals 12, I would subtract 4 first. So that's what I'm going to do. I'm going to subtract 4 from both sides. Okay, and when I do that, I get 2 times the absolute value of x minus 5 equals 8. And then, just like if this was 2x equals 8, I would divide both sides by 2. So that's what I'm going to do next, is divide by 2 on both sides. That cancels those out, and I get absolute value of x minus 5 equals 4. And now it's just like the problems you were doing that we've done up to this point. And so I'm going to split up into my two equations, one for a positive value, so I keep x minus 5 the same, equals 4, and one for the opposite value, so I say negative x minus 5 equals 4. And then I solve both of those equations. So I'm going to add 5 to both sides, x equals 9, or here I distribute negative x plus 5 equals 4, negative x equals negative 1, like if I subtracted 5 from both sides, and then divide by negative 1, I get x equals positive 1. And there's my answers. So that's our first video on absolute value equations. We'll practice this more in class. Thanks for watching.